Hi, my name is Lori Calderon and I am going to be presenting my test 3. So, for number 1, it says, giving conditional statement. If a number is prime, then it is odd. State the hypothesis. A number is prime. State the conclusion. It is odd. Is it true or false? I put false for the reason is the number 2. 2 can be a number is prime. That's true, but it is not odd. That's why I chose this is false. For this statement, I put P in place Q. Now let's start with 1A. A number is prime if and only if it is odd. Now this is a biconditional statement. Our hypothesis is a number is prime. Our conclusion is it is odd. So our symbolic form would be P if and only Q. And is it true or false? I put false because, example, this is 2 again. 2 is prime, but it is not odd. So therefore, this conclusion is false. Is it logically equivalent to the statement above? If a number is prime, then it is odd? No, it is not. 1B. The statement is, being an odd number is significant for being prime. So being an odd number is our Q. Being prime is our P. So this one is Q implies P, which is Q is a necessary condition for P. And is it true or false? I wrote false because let's use example 9. 9 is odd. That's true, but 9 is not prime. So therefore it is false. So this conclusion is false. Is it logically equivalent to the statement above? If a number is prime, then it is odd. No, it is not. So 1C. The statement is, if a number is odd, then it is prime. So for my symbolic form, I put P. Q implies P, which is Q is a necessary condition for P. Is it true or false? This is false. The reason why, let's use again 9. 9 is odd, but 9 is not prime. Therefore, this is false. Another example would be 99. 99 is odd, but 99 is not prime. So therefore, this is false. So, is it logically equivalent to the statement above, which is if a number is prime, then it is odd? No, it is not. So for 1D, being an odd number is necessary significant for being prime. So P, being prime. Q is being an odd number. So this is a biconditional statement. It's just flipped over. So P if and only Q. So for this statement, is it true or false? I put false because I used the example 99 again. 99 is odd. True. 99 is not prime. False. Therefore, this statement is false. Is it logically equivalent to the statement above? If a number is prime, then it is odd? No, it is not. So let's move on to 1E. The statement is, the number is not prime or odd. So this is what I call the negation of P or Q. This is De Morgan law. So this is what it's saying here, that is it true or false? This is false because 1 is not prime, but 1 is not odd. 2 false equals a false. Is it logically equivalent to the conditional statement? If a number is prime, then it is odd? No. So that's why I chose false, and it is not logically equivalent. Let's move on to 1F. If a number is not prime, then it is not odd. So 1F, it is the negation of P implies the negation of Q. So the negation of Q is a number is not prime. So the negation of Q is it is not odd. This is what you would call a inverse statement, which is if the negation of P, then the negation of Q. It is false when negation of P is true and negation of Q is false. So that's why I chose false. Is it logically equivalent to the conditional statement? No, it's not. So then we move on to 1G. If a number is odd, then it is not prime. If a number is odd, That is our Q statement. Is it not prime? That is our negation P. It is not prime, therefore it is not P. So if for my symbolic form, I put Q implies not P. So that's why I put true or false? False. And is it logically equivalent to the conditional statement? No, it is not. So as you can see, I got from 1A to 1G, none were logically equivalent. And from 1A to 1G, they were all F. Remember, 1A, I put P if and only Q for symbolic form. 1B, I put Q implies P. 1C, Q implies P. 1D is Q if and only P. And 1E, the negation of P or Q. 1F, the negation of P implies the negation of Q. 1G, G implies the negation of P. So that's why I did page 3. Now let's move on to page 4, which is construct a truth table that verifies which symbolic answers from 1A to 1R are logically equivalent. On row 1, write the symbolic answers for each statement number 1. After you do this section, you might need to change your answers on LE column on number 1. So, again, 1A is P if and only Q. This is a biconditional statement, which is P if and only Q. It is true when both P and Q are true and when P and Q are false. So 1A, let's look at row 2 and row 5. Those are both false. Those are both true. Row 2 and row 5 are both true. To get these true answers, P and Q on row 2 have to be true to get true. And for row 5, P and Q have to be both false to get a true. So let's move on to number 1B, which is Q implies P. If Q, then P. This is a converse statement. So it's false when Q is true and P is false. Otherwise, it is true. So let's look at this. For 1B, the only way it could be false if you look at row 4. So it has to be Q has to be true and P has to be false for it to be false. So that's how we get false. Let's look at 1C. If Q, then P. This is another converse statement. So it's false when Q is true and P is false. Otherwise, it's true. Again, 1C, let's look at row 4. Q has to be true and P has to be false for 1C to be false. So let's look at 1D, which is Q if and only P. It's true when both P and Q are true and when P and Q are false. Again, 1D is logically equivalent, you would say, to 1A, right? So 1D is, look at row 2, Q has to be true and P has to be true, so you could get a true. Now 1D, let's look at row 5. Q has to be false and P has to be false for 1D to be true. Remember, 1D is logically equivalent to 1A. Now, let's look at 1E. The negation of P or Q. This is the De Morgan law number 2. Only true when the negation of P and negation of Q are true. Otherwise, they are false. So 1E, let's look at row 5. For example, the negation of P has to be true and the negation of Q has to be true, so they could both be true. So that's how we get on 1E row 5 it is true. So let's move on to column 10, which is 1F. The negation of P implies negation of Q. That is the inverse statement, which is if negation of P, then negation of Q. It's false when negation of P is true and Q is false. Otherwise, it is true. Again, let's look at let's look at row 4. On row 4 and 1F, it is false. The only way to be false, negation of P has to be true and negation of Q has to be false. This 1F, you could say it's logically equivalent to 1B. they have the same answers. And lastly, it is 1G, which is Q implies negation of P. If Q, then not P. So it says, it is only false when Q is true and the negation of P is false. Otherwise, it would be true. Again, let's look at 1G, row 2. So G has to be true and the negation of P has to be false for this statement to be false. Now this statement, all the other ones are true, and row 2 on 1G column 11 is false. So that is good. So that's how I got row 4. Now let's do number 3. It says determine the relationship of the listed conditions with respect to the constant multiple of 6. For your answer, select A, B, C, or D. Then include a Venn diagram to show the relationship between the sets that are being compared. So we have A, necessary but not significant. We have B, significant but not necessary. We have C, necessary and significant. Then we have D, not necessary and not significant. So remember, P equals multiple of 6. Okay, so they gave us an example here, which that example helped me a lot. So now let's look at number 1. Number 1, well, let's look at the directions. Place your A, B, C, or D answer in each blank below and include the Venn diagram for each problem on the next page. It says number 1, B, being a multiple of 12. So being a multiple of 12 is significant but not necessary for being a multiple of 6. This is true because a multiple of 12 is a proper subset of multiple of 6. So that's how I got number 1. Now number 2 is being a factor of 6. I got the answer D, not necessary and not significant. So it is being a factor of 6 is not necessary and not significant to being a multiple of 6 unless the factor of 6 is 6. We have a common number, which is 6. So that's how I got that answer. Now for number 3, it says being a number less than 0. So I got letter D, which is not necessary and not significant. So being a number less than 0 is not necessary and not significant to being a multiple of 6. When I was constructing this one, I had to visually see it before I could choose an answer. So what I did was I did the numbers less than 0, which are negative, then the multiples of 6. So that's why that's how I did my visualization. So number 4 is D, being a counting number between 2 and 5. So counting numbers between 2 and 5 are 3 and 4. So then it says not necessary and not significant. Being a counting number between 2 and 5 is not necessary and not significant to being a multiple of 6. So again, I constructed the Venn diagram, and that's how I was able to get this one. So then on number 5 is being an odd counting number between 2 and 5. Being an odd counting number between 2 and 5 is not necessary and not significant to being a multiple of 6. So again, I constructed my Venn diagram, and that's how I was able to get this answer. Now the Venn diagram, it's what helped me. So for number 1, it says being a multiple of 12. So you know that your multiple of 12 is a subset of multiple of 6. So when you draw the Venn diagram, which I'll show right here, you get your multiple of 12, and then your multiple of 6 would be your superset. And your multiple of 12 is your subset. So number 2 is being a factor of 6. So what I did is called a overlapping Venn diagram, which is B overlap same, which I did here. B overlaps A. So my factors of 6 are, of course, 1, 2, 3, and 6. So my multiples of 6 are 6, 12, 18, goes on. So what do they have in common? The number 6. So that's why I did an overlapping Venn diagram. So being a number less than 0, set B would be my less than 0 and set A would be multiples of 6. What I constructed was a disjoint Venn diagram, so which they have no numbers in common. So then number 4 I did is being a counting number between 2 and 5. So what I did is, again, another disjoint because I didn't see no numbers in common. Being a counting number between 2 and 5, of course, is 3 and 4. Multiples of 6, again, 6, 12, 18, 24. Again, no common number. So that's why I did a disjoint set for number 4. Set B, set A. And then for number 5 is being an odd counting number. Again, disjoint set. Because numbers between 2 and 5, or odd counting numbers between 2 and 5, are my set A, and multiples of 6, are my set B. Odd counting numbers between 2 and 5 are my set B's, and my multiples of 6 are my set A's. Again, I did a disjoint set. Again, for numbers 3, 4, and 5, they are disjoint set because they're not necessary, not significant. Number 2, again, it is not necessary, not significant, but they do share a common number of 6. So that's why I did an overlapping. And for number 1, I did the Venn diagram, which I had a P and a Q, and I had a subset and a super subset. So this helped me get back to page 5. So with that being said, if you have any questions or need clarification, please let me know. That way I could maybe redo the video for you or do something else for you. Again, I did all the answers that I needed. Thank you.